Group 11's battery repurpose and salvage. The objective here was to meet the town's need for mobile energy use, which includes radios, walkie-talkies, AEDs, and everything else. The materials needed are wrenches, sockets, crowbar, drills, and other necessary tools, a map to locate the high battery concentration areas of your town, rubber gloves and masks, eye protection, resistors, amperage meter, wires, and a multimeter, then a battery cell. For the instructions, first, you find the nearest hardware store to acquire the tools needed. Second, you salvage car batteries by breaking into an abandoned car, exposing the battery, and unscrewing and removing the car battery. Next, you find rechargeable AAA and AA batteries, which you can do by consulting a map of the local area, finding high battery concentration areas such as schools or hardware stores. Then you set up a recharging station in a central part of town. Then, to actually go through with the whole idea of setting up the recharging station, you need to charge the car batteries that you harvested. So you transport the car batteries to the substation of the nearby hydroelectric power plant, the dam. Then you charge the car batteries using the hydroelectric power so that it fills with energy. Then you transport the car batteries to the recharge station. You connect the car batteries to the battery cells, and then you put the batteries in the battery cells. And then you distribute the charged batteries to the people in need. That is all.
Some safety concerns are exposure to the chemicals in the batteries, so make sure to wear the proper safety gear such as gloves, goggles, and masks so that you aren't exposed to any dangerous chemicals. There is risk of electrocution at the substation, so try to avoid touching things, wear heavy gloves, rubber gloves. When transporting the car batteries, they can be very heavy, so it's recommended to use a wheelbarrow or a wagon or some other method of carrying. And when you're breaking into cars, there's a risk of combustion, so just be very cautious when taking the batteries out of the cars.
So the community benefits are based on communication and light. The first one is that you can use walkie-talkies and flashlights to survive zombies. This is based on the idea that communication at a distance with walkie-talkies is useful to be in touch if there's any external danger coming into the city and to protect basically the citizens that are living there. Communication helps also in finding medication and food resources, so that still works in a communication at a distance that we can use with the walkie-talkies, and that's the electricity that we're putting in. And if someone is lost, both light and walkie-talkies are useful to find the person. The community benefit is based on providing electrical resources to sustain a safe life and while hiding from zombies. Light provides protection because the citizens will be able to see clearly in the night and evacuate or hide if necessary. And then the most common questions, the frequently asked questions, would be like, if battery is not recharging, just make sure that the charges are placed correctly. So it's the negative on the negative side that needs to be placed. So it's turned on the opposite, and positive on the positive side. And then what type of batteries are we used? It is represented on the diagram. They are AAA batteries. And how do I transfer car batteries? Well, just like take them off, and especially like someone that is severely strong could carry just one battery. And why AA batteries? They are the type of batteries used by flash bulbs.
Okay, so I'm Henry. I'm talking about battery lifespan. So the batteries we use will degrade over time. Since concrete washing is in a cold climate, the batteries will degrade slower, but they'll still degrade as we use them and recharge them. For single-use batteries, they have a lifespan of about 5 to 10 years, so they'll be unusable after a pretty short period of time. Lithium batteries from cars will also degrade over time, losing battery capacity. So this is a chart I made of how they lose capacity. It shows how it degrades over the span of 10 years. It goes about 80% capacity after 10 years, meaning it'll need to be recharged more often as it loses capacity. So yeah, this is a factor.
So now, as to how all of this works, this is our reflection or scientific principles part. First off, a battery is a series of 2 or more electrochemical cells in which electrons flow through a conductive medium from an anode to a cathode. In the process, they create a current while oxidizing the anode and reducing the cathode. Primary voltaic cells, which were mentioned earlier, are non-rechargeable batteries. They are one-time use kind of thing. Those, once we scavenge them and use them, there's not much more we can do with them. However, the scavenged lead-acid batteries and other rechargeable ones that we have found around the town that we have scavenged, those are in fact very helpful. Let's see, because they can be recharged. This is because the redox reactions which generate the current are reversible, and by applying pre-existing current in the opposite directions, it undoes the reaction, meaning that it can be done in the forward direction again, in other words, restoring its charge. This is done through, well, for lead-acid batteries, which are the most common car batteries, this is done through a series of half reactions in which a lead anode and a lead-4 oxide cathode react with sulfuric acid, which can ionize into hydrogen ions and hydrogen sulfate. The following half reactions demonstrate this, in which we have lead. Well, it would be much easier to show you because there's a lot of complicated equations there. If you can see, they're somewhere up there, which I will now read out. We have lead plus hydrogen sulfate creates lead sulfate and hydrogen ions and 2 electrons, and lead oxide with 3 hydrogen ions and hydrogen sulfate and 2 electrons make lead sulfate and 2 H2Os, which as we know is water, for an overall reaction of lead plus lead oxide plus 2 dihydrogen sulfates should make 2 lead sulfates and 2 waters. And so when a reverse current is applied, these reactions are undone so that they can then be redone again to generate a current. The other rechargeable batteries that we have found and scavenged undergo similar processes of reduction and oxidation in reversible reactions, generating or requiring electron flow to do so. However, these may be a variety of lithium-ion, nickel metal hydride, nickel zinc, or nickel cadmium batteries, and so have different half and overall reactions.
So this is a diagram of a lead acid battery, and you can see that the reaction between the sulfuric acid and the lead is what produces the electrons or the electrical current. So this flow of electrons is what essentially creates electricity. These are the half reactions that were discussed earlier, and to recharge, you basically just reverse these reactions.
Batteries can be found in 3 main zones: commercial zones, residential zones, and industrial zones. Commercial zones will usually contain hardware stores, which can contain AAA or AA batteries, and even car batteries. Residential zones, where you'll find houses with cars, you'll be able to find AA and AAA batteries, and the cars, you can find car batteries. And then industrial zones will contain industrial buildings such as factories. You can find AA and AAA batteries in them. Then cars can be found on pretty much every zone, which will contain car batteries. Then schools can be found in near residential zones, and they'll have items such as calculators that have AA or AAA batteries you can get.